truck engine, cheap interior, not a real sports car. That was the verdict on the Chevrolet Corvette C5, filed before the first test car reached a track. It didn't matter that the lap times were faster than a Porsche 911. It didn't matter that the race version won its class at Le Mans 2 years running, against factory entries from Porsche and Ferrari. The conclusion had already been written. A car with a chassis 50% stiffer than what came before it. An engine still in production 30 years later. A floor built from a material borrowed from boat hulls and aircraft panels that literally cannot rust. 2 Le Mans class victories on its record, and somehow it was never quite enough. So, how does a car this capable almost not exist at all? The answer starts inside General Motors, in the early 1990s, when someone asked a question that should never have needed asking. Is the Corvette worth keeping? The answer, according to an internal study during the recession years, was effectively not. The Corvette wasn't profitable on a standalone basis. The study reportedly recommended discontinuation, and for a real stretch of time, that was a serious possibility. The car that would become the C5, the car that would go to Le Mans and embarrass European sports cars at half their price, almost died in a boardroom before a single engineer touched a drawing. It survived because a group of GM executives argued that the Corvette's value to Chevrolet wasn't fully visible in a profit and loss column. It was an engineering demonstration, a brand anchor, something that proved Chevrolet could build a world-class car. That argument won. But it came with conditions. The C4, the generation the C5 would replace, had problems that everyone in the building knew about. The interior quality was below what European competitors offered at similar price points. The chassis flexed in ways that blunted the suspension's ability to do its job. And in 1992, the Dodge Viper arrived with 400 horsepower from a 10-cylinder engine and immediately repositioned what a domestic performance car was supposed to be. The C4 was already behind. The C5 had to be different. Dave Hill, the C5's chief engineer, built the development program around named competitors and measurable targets. The Porsche 911 Carrera was the handling benchmark. The Ferrari 355 was referenced in performance discussions. These were not marketing comparisons invented for a brochure. They were instrumented development criteria that had to be verified on a test track. The directive was simple. Build something that competes with the best European sports cars on every measurable dimension, and do it for under $50,000. The C4's interior reputation was part of the brief too. General Motors knew that criticism had damaged the Corvette's credibility with buyers who were cross-shopping European alternatives. The C5 development included specific supplier changes and materials upgrades to address exactly that. New vendors, new specifications, per unit cost went up, but the competitive target required it. The C5 Coupe launched in 1997 at approximately $37,000. The Porsche 911 Carrera, at the same moment, was approximately $70,000. The Ferrari 355 was closer to $130,000. Those price gaps would matter enormously, but not in the way General Motors engineers hoped. Not as proof of value. As evidence, in the minds of the people who had already made up theirs, that something cheaper must be something lesser. But the car had not even been tested yet, and the engineers building it were not working to a feel-good brief. They were working to a structural target, a weight distribution target, and a powertrain output target. Each one documented, each one verifiable. The first question was the one that would define everything else. What's worth knowing is that while those engineers were hitting every target they set, a separate conversation was already happening in the automotive press. One that had nothing to do with lap times, nothing to do with torsional rigidity numbers, and everything to do with a decision that had already been made before the first test car reached a track. How do you build a chassis rigid enough to make all of that work? The C4's fundamental problem wasn't the engine or the suspension geometry on paper. It was the structure those components were attached to. A chassis that flexes under load cannot deliver consistent suspension behavior because the geometry the engineers designed shifts every time the body twists. The suspension can't do its job if the platform it's mounted to is moving underneath it. That was the C4's ceiling, and everyone at General Motors knew it. The C5 had to start with the bones. General Motors' solution was hydroformed aluminum frame rails. The process works by taking an aluminum tube and forming it into complex three-dimensional shapes using hydraulic pressure from the inside, rather than stamping separate pieces and welding them together. That distinction matters more than it sounds. Conventional stamped and welded frame construction creates weld seams at stress concentration points. Those seams are inherently weaker than the surrounding material. Hydroforming produces a continuous tube, no seams, no stress risers, and a geometry that can vary along the length of the rail without any interruption in the material. The result was a frame that was approximately 50% stiffer in torsion than the C4's structure, not incrementally better, 50%. To put a number on that, the C4's torsional rigidity sat at roughly 2,600 pound-feet per degree of twist. The C5 came in at approximately 4,300. That improvement is the specific engineering reason the C5 handles differently from everything that came before it. The suspension geometry stays where the engineers put it. The car behaves the way it was designed to behave. The floor structure added another layer of thinking borrowed from outside the automotive world entirely. The C5's floor uses balsa wood sandwiched between fiberglass composite skins. The same construction principle is found in boat hulls and aircraft panels. It provides rigidity with minimal weight, and it cannot rust. Not less likely to rust. Cannot. A C5 that spent 25 years in a northern climate still has a structurally intact floor, while a steel-floored European sports car from the same era and the same environment may not. The composite construction eliminates that failure mode entirely. Then there is the transmission. In a conventional front-engine sports car, the gearbox sits immediately behind the engine, which puts a significant block of mass toward the front of the vehicle. The C5 moved the transmission to the rear axle, connecting it to the engine through a torque tube that runs the length of the cabin floor. Moving that mass rearward shifts the weight balance. The result was a documented 51 to 49 front-to-rear weight distribution. A conventional inline layout in a front-engine car of this size typically produces something closer to 55 to 45, sometimes worse. The 51 to 49 ratio is the engineering basis for the C5's handling balance. More equal weight distribution reduces the understeer tendency that front-heavy cars develop at the limit of cornering when the front tires are already being asked to do too much. The torque tube itself is a precision component. It requires specific alignment, but it does not wear out under normal street use, and the benefit it delivers is permanent. Every C5 that left Bowling Green carried that weight distribution as a standard feature of the architecture, not an option, not a performance package. It was built into the bones of the car from the first day of production. The chassis was the foundation. What sat on top of it was the argument that would generate the most controversy. The LS1 was a clean sheet design. 5.7 liters, aluminum block, iron cylinder liners, and a single camshaft mounted in the block, driving the valves through push rods. That last detail, the pushrod overhead valve architecture, became the thing critics reached for before they had finished reading the spec sheet. European sports cars of the era used overhead cam engines, twin cams in many cases. The automotive press had already decided, somewhere in the decade before the C5 arrived, that overhead valve pushrod architecture was old technology. It did not matter what the output numbers said. The layout itself was the verdict, and that verdict said a pushrod engine belonged in a truck, not a serious sports car. The truck comparison was technically accurate in one specific way. The LS1 shares its basic Gen 3 small block architecture with LS family engines that went into GM trucks and SUVs after 1997. Same pushrod layout, same aluminum block design, same general engineering lineage. That much is true. But technically accurate and functionally meaningful are different things, and the critics who use the truck label as a dismissal skip the second part. The LS1 in the C5 used Corvette-specific cylinder heads, a Corvette-specific camshaft profile, a Corvette-specific intake manifold, and a Corvette-tuned exhaust system. The truck application of the same engine family, a 5.3-liter variant, produced approximately 270 horsepower. The LS1 in the C5 produced 345 horsepower at launch, revised to 350 for the later production years. That is not a marginal difference. That is a different engine in every characteristic that matters to a driver, built on a shared architectural foundation, the same way a racing engine shares architecture with a road car. The lineage is real. The equivalence is not. And then there is what the LS1 does not require: no timing belt. The LS1 uses a timing chain, and the chain's documented failure rate at normal service intervals is effectively zero. No valve adjustment. The hydraulic roller lifters handle that automatically. The scheduled maintenance for an LS1 comes down to oil changes, spark plugs, and accessory belt replacement. For a sports car engine producing this output, that service profile is almost unreasonably simple. A Ferrari 355 of the same era requires a full timing belt service at significant intervals, a job that involves removing the engine and costs several $1,000s at a specialist shop. The LS1 requires none of that. Car and Driver tested the C5 Coupe in 1997, 4.7 seconds to 60 miles per hour. Road and Trax comparison tests placed the C5 competitively against the Porsche 911 in handling and braking metrics. These weren't favorable impressions or editorial generosity. They were instrumented results, printed in the same publications that the automotive world treated as definitive. The data was there from the first year of production. And still, the pushrod label stuck. The truck engine comparison circulated. The criticism wasn't that the numbers were wrong, it was that the numbers came from the wrong kind of engine, built by the wrong kind of company, and sold at the wrong price to be taken entirely seriously. Here is what that argument actually required people to believe: that 345 horsepower from a naturally aspirated V8 with no timing belt and a 50,000-mile service interval was less impressive than a similar output from an engine that cost 3 times as much to maintain. And that cost comparison is worth holding on to, because later in this story there is a specific maintenance job on a Ferrari 355 from the same era that runs several $1,000s at a specialist shop and requires removing the engine entirely. The LS1 has no equivalent. That number, and what it reveals about the real cost of European prestige, is coming. That a car hitting 4.7 seconds to 60 miles per hour wasn't a serious sports car because the architecture powering it had also been used in a pickup truck. The press acknowledged the numbers. Then they found other reasons to keep their distance. The automotive press didn't ignore the C5's lap times. That would have been easy to call out. What actually happened was more subtle and in some ways more difficult to argue against. The pattern in period coverage was selective acknowledgement. A review would note the 0 to 60 time. It would confirm the structural improvement over the C4. It would place the C5 competitively in a comparison test against a Porsche or a Ferrari on measured metrics. And then it would pivot. The interior quality, the badge, the type of buyer this car attracted. The conclusion, written before the first paragraph, remained unchanged regardless of what the data said. The C4 had given critics the material they needed. Years of genuine interior quality complaints, fit, and finish that fell short of what European competitors offered at comparable prices. A reputation for attracting buyers who wanted horsepower without the refinement that a Porsche or a Ferrari implied. That reputation had been built over a decade. It was already filed away before the C5 reached a single test track. GM knew this going in. The C5's development included specific interior quality targets, new suppliers, upgraded materials, changes designed to address exactly the criticism the C4 had drawn. The effort was real, and the investment was real. But a reputation doesn't reset on a launch date. The C5 arrived carrying the C4's history, and the press applied the C4's conclusions to a car that had been built specifically to answer them. The price gap made it worse, not better. The 911 Carrera in 1998 cost approximately $70,000. The C5 Coupe was $37,000. That gap was supposed to represent value. What it actually represented, in the minds of people who had already decided, was confirmation. If it costs half as much, the reasoning went, something must have been left out. The engineering data didn't support that conclusion. The lap times didn't support it, but the assumption didn't need support. It was structural. There is a specific prestige psychology at work in how prestige is assigned to objects. Price becomes a proxy for quality when quality is difficult to measure directly. And for most buyers and most reviewers, measuring quality directly meant sitting in the car and forming impressions, not running torsional rigidity tests or comparing reciprocating mass calculations. The C5's interior was better than the C4's. It wasn't a Porsche interior. And in a world where the interior impression is what shapes the written conclusion, that gap was the one that mattered most to the people writing the reviews. The Corvette also carried a brand association that no single generation could undo on its own. American muscle car, boulevard cruiser, something for buyers who wanted straight-line speed without the sophistication that a European badge implied. That categorization had been set before the C5 existed. It didn't come from anything the C5 did wrong. It came from what the Corvette had been in previous decades and from what American performance cars were assumed to represent in a press culture that had been shaped by European engineering standards. What that meant in practice was that the C5 had to do more than match European competitors. It had to exceed them so clearly and so repeatedly that the conclusion couldn't hold. And even when it got close to that threshold, the goalposts moved. The interior, the badge, the price. There was always one more reason to keep the distance. While the press was writing its conclusions, the engineers were building the argument that would matter most on a racetrack in France. The 24 Hours of Le Mans is not a marketing event. It is not a venue for press releases or carefully staged performance demonstrations. It is a race that has been running since 1923, and the results are documented in official ACO records that do not get revised based on who built the winning car or where it was assembled. In 2001, the Corvette C5R won the GT class at Le Mans. In 2002, it did it again. 2 consecutive GT class victories, back-to-back, against factory GT entries from Porsche and Ferrari, documented in the official results of the most prominent endurance race in the world. The distinction between GT class and overall matters, and it deserves to be stated clearly. The overall victories in 2001 and 2002 went to the Audi R8, a factory prototype with technology and a budget in a completely different category from any GT car on the grid. The C5R did not beat Audi's prototype. What it did was win its class, which is the class it was built to compete in, against the best GT cars that Porsche and Ferrari could put on the circuit. That is the accurate description of what happened. It is also, without any qualification needed, a significant result. The relationship between the C5R race car and the production C5, sitting in Bowling Green dealerships at $37,000, is architectural. The C5R uses the LS engine family. It uses the same basic structural concept as the production car, developed into full race specification. The production vehicle provided the regulatory homologation foundation that made the race program possible. You cannot enter a factory GT program at Le Mans without a production car at its base. The car that everyday buyers were purchasing was the technical and regulatory foundation for a race car that won at Le Mans. That connection is not rhetorical. It is how GT class racing works. What the LS architecture could do in competition specification had now been verified at the highest level available to a GT class entry. An engine family that critics had labeled a truck motor had just powered a factory race car to back-to-back class victories at a race that Porsche and Ferrari treat as a primary measure of their engineering credibility. The result was in the record books. It was primary source verifiable. It was not a simulation or a controlled track day or a manufacturer's claimed figure. The victories did not change the cultural narrative. That is the part worth sitting with. The automotive press that had already filed the C5 under muscle car did not revisit its conclusions because a race-derived version of it won its class in France. The same publications that had noted the C5's lap times and then pivoted to the interior quality noted the Le Mans results and largely continued. The Corvette was still the Corvette. The badge still carried what the badge had always carried. 2 class wins at Le Mans against factory Porsche and Ferrari GT entries were acknowledged and absorbed into the existing story rather than changing it. That is not a small thing. That is the specific moment where the gap between measurable achievement and received reputation becomes impossible to explain through engineering alone. The data was as clean and as public as data gets in motorsport, and it was not enough to move the conclusion that had already been written. The Z06 arrived that same year, and it made the argument even harder to dismiss. Because for the 2002 model year, General Motors did something inside that engine that belonged in a different category entirely. A material choice you would expect to find in a purpose-built racing engine or a fighter jet, not in a $50,000 American production car available at a Chevrolet dealership. That detail is what separates the Z06 from everything else on this list, and it is coming next. The Z06 introduced for 2001 was not a trim level of the coupe with a different badge and a sport package. It was a different car. The body structure was distinct. The Z06 used a fixed roof hardtop without the removable panel hardware the coupe had. That hardware, the mechanisms, the seals, the glass panel itself, added approximately 60 pounds to the coupe's structure. The Z06 simply did not have any of it. Fixed roof, no removable section, no compromise. The weight reduction was not incidental. It was the point. Every engineering decision in the Z06 was organized around a single priority, track use, and the body structure reflected that before you opened the hood. Under the hood was the LS6, same 5.7-liter displacement as the LS1 in the standard coupe. Different everything else. Revised cylinder heads with larger intake and exhaust ports, a more aggressive camshaft profile, a higher flow intake manifold with revised runner geometry. The result for 2001 was 385 horsepower from the same displacement that the LS1 used to produce 350. That improvement came entirely from breathing. No additional displacement, no forced induction, better airflow, and a more aggressive camshaft. Then for 2002, the LS6 was revised again to 405 horsepower. The specific internal change that got it there was titanium intake valves. Titanium intake valves are significantly lighter than equivalent steel valves. That reduction in valve train mass allows the engine to rev more freely, follow the camshaft profile more precisely at high RPM, and sustain that behavior under the kind of sustained heat loading that endurance racing generates. Titanium valves are found in purpose-built racing engines. They appear in a small number of high-performance production engines where the manufacturer has decided the cost is justified by the performance goal. In the 2002 Z06, they were a production specification component in a car with a base price of approximately $50,000. Not a racing homologation run, not a limited edition, a production car, assembled at Bowling Green, available to anyone who could write the check. Road and track and car and driver placed the Z06 against the Porsche 911 Carrera and the Ferrari 360 in multiple comparison tests from 2001 through 2004. The Z06 was $50,000. The Ferrari 360 was approximately $130,000. The press acknowledged the performance gap. The Z06 was faster on track. The instrumented numbers said so, repeatedly, across multiple publications, across multiple years of testing. For the 2003 and 2004 model years, the Z06 added magnetic selective ride control as an available option. The system uses Magnador heological dampers, shock absorbers filled with iron particles suspended in fluid. Running an electromagnetic current through the damper piston causes the iron particles to align, which changes the fluid's resistance and therefore the damper's stiffness. The response time is approximately 1 millisecond, No mechanical adaptive damper of that era could match that. Stability control as a federal mandate for all new vehicles was still years away. Here was a $50,000 American sports car offering suspension technology that would not become broadly standard for more than a decade. Available as a defeatable option, the driver could switch off entirely for track use. By 2003, the Z06 had titanium intake valves drawn from racing engine specifications, Magnador heliological suspension technology ahead of any regulatory requirement, back-to-back Le Mans class victories on its race program record, and comparison test results in major publications placing it ahead of cars costing more than twice as much. The press acknowledged it, the comparison tests ran, the lap times were printed, and the Corvette was still the Corvette. 25 years after the first one rolled out of Bowling Green, the C5 makes an argument that has nothing to do with nostalgia. Approximately 212,000 C5 were built across the full production run. That number is vastly larger than any European sports car competitor from the same era. And production volume, unglamorous as the concept sounds, is the reason the C5 is still a practical car to own today, rather than an expensive collector piece requiring specialist attention for every service interval. Parts are available through standard channels at prices calibrated to a high-volume domestic run. Brakes, suspension components, engine internals. A C5 owner sourcing parts is not navigating a low-volume European supply chain. They are drawing on the same ecosystem that supports every LS-powered GM vehicle built over the last 3 decades. The composite body panels cannot rust through. That fact compounds quietly over time. A C5 in a northern climate with salt exposure still has structurally sound body panels, while a steel-bodied European sports car with equivalent exposure and equivalent age may not. The failure mode simply does not exist. Cracking, fading, delamination from impact damage are all possible. Rust perforation is not. For a car approaching 30 years old, that distinction is the difference between a restoration project and a driver. The LS architecture launched in the 1997 C5 is still in production today. Nearly 30 years of continuous development across trucks, SUVs, and performance cars means that an LEL S1 owner sourcing internal components is not working against a discontinued parts ecosystem. They are drawing on the same supply chain as current production vehicles: pistons, rings, bearings, gaskets, camshafts, available through standard automotive parts channels at prices that reflect the architecture's ongoing production scale, essentially indefinitely. The C6 that replaced the C5 in 2005 retained the hydroformed structure, the rear transaxle layout, the composite body, and the LS architecture. The C5 wasn't replaced in any meaningful engineering sense. It was continued because the philosophy it established was correct, and GM knew it was correct, and the C6 is the evidence of that conclusion. The gap between what the data showed and what the cultural narrative said about this car is still visible today in what C5s sell for relative to their European contemporaries from the same era. That gap is not an accident. It is the specific, persistent, measurable evidence that perception, once established, is harder to move than a lap record. 2 Le Mans class victories. Titanium intake valves in a $50,000 production car. A 51 to 49 weight distribution achieved through a transmission mounted at the rear axle. The evidence was always there, documented, verified, printed in the publications that shaped the conversation. The most underrated Corvette ever built is still underrated. That's the most honest thing you can say about it. If this era of over-engineering and cars built to last is something you value, the next video is worth your time. In 1989, Toyota gave a team of engineers a blank check and told them to chase perfection. The result outperformed Mercedes and BMW at half the price. So, what happened after that? Click on this to find out.